Every year, millions of tons of plastic waste enter rivers and eventually flow into the oceans, harming wildlife and polluting ecosystems. Cleaning rivers manually is often expensive, time consuming, and dangerous. To address this problem, engineers are developing autonomous river cleaning robots that can operate with minimal human intervention. In this project, we explore the design of an autonomous trash collecting river drone that uses machine vision to detect floating waste and solar power to operate sustainably throughout the day. The drone is designed as a small catamaran style vessel with two floating pontoons connected by a lightweight frame. This structure provides stability and allows the drone to move smoothly through the water. Between the pontoons is an opening that guides floating trash toward the collection system. The frame is made from lightweight, waterproof materials to improve durability and energy efficiency. The design must also support the batteries, solar panels, sensors, motors, and storage container while maintaining good balance and performance. Machine vision is one of the key technology used in this project. A camera mounted on the drone continuously captures images of the river surface. These images are analyzed by an on-board computer using artificial intelligence software trained to recognize common types of floating waste. The system can identify objects such as plastic bottles, cans, and plastic bags. Once trash is detected, the software determines its location and guides the drone toward it. This allows the drone to find and collect waste automatically without constant human control. To move safely through rivers, the drone uses an autonomous navigation system. GPS helps determine its location, while a digital compass provides direction information. Obstacle detection sensors, such as ultrasonic sensors or LIDAR, help the drone avoid rocks, boats, and other objects in the water. The onboard computer combines data from these systems to calculate safe routes. When trash is detected, the drone adjusts its path to collect the waste while avoiding obstacles. Although the drone is designed to operate autonomously, remote monitoring remains an important feature. A wireless communication system allows the drone to send operational data to a control station in real time. Information such as battery level, GPS location, storage capacity, and system status can be monitored by operators. If necessary, operators can manually override the autonomous controls or update mission parameters. This communication capability improves safety, allows for performance tracking, and ensures that the drone can be managed effectively during long cleanup operations. The drone is powered primarily by solar energy, making it an environmentally friendly solution. Solar panels mounted on the top of the vessel capture sunlight and convert it into electricity. This energy is stored in rechargeable batteries that power the motors, sensors, camera, and computer system. Solar charging helps extend operating time and reduces the need for frequent battery replacement or external charging. As a result, the drone can work for longer periods while using clean, renewable energy. Once the drone reaches a piece of floating waste, the collection system removes it from the water. The trash enters the channel between the pontoons and is lifted by a conveyor belt or scoop mechanism into a storage container. The system is designed to collect debris efficiently while minimizing the amount of water brought on board. Sensors monitor the container's capacity and notify the system when it is full. This allows the drone to operate effectively during cleanup missions. After the storage container reaches its capacity or the battery level becomes low, the drone returns to a designated docking station. Using GPS and navigation sensors, it can locate the docking area and approach it safely. At the station, collected waste can be removed for sorting and recycling. The batteries may also be recharged if additional energy is needed. An efficient docking and disposal process ensures continuous operation and reduces the amount of human labor required to manage the cleanup system. Before deployment, the drone must be tested to ensure reliable performance. Engineers evaluate its ability to detect trash, navigate autonomously, avoid obstacles, and collect waste successfully. Testing is usually conducted in controlled environments such as ponds or calm river sections. Data collected during these tests helps improve the machine vision system, navigation software, and collection mechanism. Regular testing ensures that the drone can perform effectively in real world conditions. Several improvements could make the drone even more effective in the future. More advanced artificial intelligence could improve trash detection accuracy and allow the system to identify different categories of waste. Larger solar panels and batteries could increase operating time. Additional sensors could monitor water quality and environmental conditions. Engineers may also develop fleets of drones that work together to clean larger sections of rivers more efficiently. Thank you for watching this project on engineering an autonomous trash collecting river drone using machine vision and solar power. I hope you enjoyed learning about how this innovative technology could help keep our rivers clean and protect aquatic ecosystems. If you enjoyed this video, don't forget to like, subscribe, and activate the notification bell so you never miss our future robotics and engineering projects. Feel free to leave a comment below and share your thoughts about this autonomous river cleaning drone. Thank you for your support and see you in the next video.